Okay, so what we're supposed to do, it says in the directions, is use the equation and the XY table. Use the equation. Okay, here's our equation. Let's circle that. Y equals 3x. And the XY table to graph the function. Fill in the scale on the graph to help you plot the points and draw the line. We're just going to let it go by one. So hear me on this. When you have a graph, a coordinate plane, that there is no numbering on it, no labeling of the grid lines on the axes. We go with an assumed one when it's that, and that's what we're going to do. So we're not going to go through all the work of numbering our number lines, our axes. That's really what they are, our number lines. So we're just going to go with every grid line represents one unit. So we really have here, when we have in this XY table, x equals -1, y is the corresponding y value is -3. How can that be written as an ordered pair? To show it on a graph. What ordered pair is x is -1 and y is -3? Wait. Yeah, in parentheses, right? Okay, let's do this first of all before we graph them. Let's write the ordered pair names for that information given to us in the table. So the x value always comes first in the ordered pair, followed by the y value. And by the way, whenever we write two numbers separated, or even if they're variable expressions, any two things that's separated by a comma in parentheses in mathematics indicates an ordered pair. Okay? So reserve parentheses around two things separated by a comma to be ordered pairs. We have other ways to write other things. Okay, now I want you to go and plot all those points on the coordinate plane. So you have 5 points using those ordered pair names. I want you to get those put on the graph, okay? Oh, let's see if I'm totally off here. Okay. And here's the deal, if after you have your points graphed, if you can line up your ruler going through them and draw a straight line going all the way through the coordinate plane, you've done a good job of graphing. Go ahead and draw the line if you can do that. If not, if there looks like there's a point that wants to be off on its own somewhere, you better figure out why it's being a rebel. So all the way through, with arrows at both ends, using your ruler as a straight edge. Do not freehand lines. There are things we can freehand, but lines is not a good idea. So don't just connect the points and then put arrows at the end. Go all the way through. Look at mine. Go all the way through the coordinate plane. Because there's a rule going on in this table. There's a rule going on in that equation that is saying, can anybody tell me what is the rule in that table? What do you do to the input to get the output? Okay? Okay, let's write that over here. Multiply the input. There's always a rule. by 3 to get the output. -1 times 3, yep, that's -3. 0 times 3, yeah, 0 times anything is 0. 1 times 3, yep, that's 3. 2 times 3, yep, that's 6. 3 times 3, that's 9, isn't it? So that seems like the rule for this one. And remember, we already know its equation. Okay, so today what we're going to be, that is really kind of the new part that we're going to be talking about is slope. Anybody think they can describe slope in this context here today? Not a contest, a context. Okay, slope is how steep the line is. Okay, so how fast is it rising or falling? But we think about what is its vertical change over what is it, how fast is it running? How much is it running? Or in other words, how much is it going over left or right? So think of a set of stairs. If you're climbing a set of stairs. Would that set of stairs be steeper if you went for every, let's say, I don't know, 2 feet? For every 2 feet, you went 2 stairs up. Or for that same 2 feet, right next door to another set of stairs, in that same distance of 2 feet, you go up 3 stairs. Which would be the steeper staircase? What do you think? Anybody think they have an idea? Okay, well, let's use this line to help us understand that then. So I'm talking about going up steps. So let's start here at the origin. And let's call this from this point right here. I will highlight mine. From this point to this point, let's say that's my steps, okay? So every grid line is going to be a step. So what happens when I go up to get across from that point? How many steps have I gone up? 3, right? Okay. Oh, well, that would be what we call our rise then. Let's go put, to get from one point to the next, I went up 3. How much do we have to go over? Run to get on. So we're right here right now. If I go up 3 steps, I'm right here right now. How much do I have to go over to get on that point? 1. So the rise is 3. The run is 1. Okay. Let's see if that works to the next one also. If I go up, if I want to get to this point right here now, so now I'm going from this point to that one. Count. Do you have to go up 3 and over 1 to land? Do it on your paper. The 2 that I have highlighted, count between those 2 points. Do you go up 3 grid lines and to the right 1 grid line? Yes? Okay. Well then, let's do something crazy like, let's start here at the origin, and let's go all the way up to that point. Tell me, count between those 2 now on your papers. Count between those 2 points. How many grid lines do you have to go up? From the origin up to here. How many grid lines did you have to go up? Danny? 12. Anybody agree with Danny? She says 12. You agree, Wade? You do too? Okay, I don't know if I can agree. Hayden? 10. Okay. Sam? 9. Everybody try counting again. Maybe we don't know how to count. Do you count the point you're starting at? Do you start there and say 1? No, you go up to the next grid line and say 1, 2, 3, 4, till you're straight across from that point. How much do you have to go up? How much do you have to go up from here to here to be straight across from that point? Plus what? Wait. 8. We got a variety of numbers here. You got 9. You got 9. Should be 9. Should be 9. So see if you can get 9. So that's a rise of 9 between this point and that point. What is the run to end up over on top of it? How much do you have to go to the right to land on it? Sam? 3. Anybody else say 3? Yeah. Okay, so the run is 3 between up 9 and over 3 between those 2 points. Tell me something about 9 compared to 3, as if we're comparing 3 to 1 here. Or in other words, what would 3 over 1 divide out to? What's 3 over 1 divide to? 3 divided by 1 is 3. What's 9 divided by 3? 3. So the steepness of this line between any 2 points should be a 3. Doesn't matter which 2 points you pick, and you do the rise over the run, and then simplify that, you should get 3, which we call the slope of the line. We'll put 3 over 1 equals 3 here. Do it like that. So 3 over 1 equals 3. 9 over 3 equals 3, doesn't it? Okay, now, I want you just to use your graph, and I want you to, from the origin, do the same thing. Just kind of like, don't miss, do what I was saying. Go from that first point of the origin. So go from the first point at the origin right here up to this one, or not up to that one, but just go up to and over 1. Where will you be? From this point here, if you go up to and over 1, will you be on the line? Right here. Yep. 2. Because I remember my thing with the staircase would be steeper, going up 3 steps at a time, or going up 2 steps at a time in the same amount of distance. Which one would be steeper? So let's just try to do this. So here's our staircase that is going 3 steps up in that distance. Now I want you to go up 2 steps and over 1. Where do you end up? On that line? I don't. And then if I go up another 2 and over 1, I'm not on that line. So it's kind of like if I just keep going up 2 and over 1, I don't end up on that line. I'm starting to not be able to see it all on mine. Which staircase is steeper, the one with the 3, a rise of 3, or the one with a rise of 2? The one with the rise of 3, isn't it? The bigger the slope, the steeper the line will be. So tell me something now about the relationship. Tell me something now about the relationship this slope of 3 has to our equation. What's going on? What is our slope? Our slope is 3. Let's go up here and just write that. Slope is 3. We'll get a pen instead of an eraser. Slope is 3. Look at this. Look what's happening in that equation. What's going on? What's going on in our rule over here? Do you see a connection anywhere at all? What's the connection? The x is being multiplied by 3, our slope, right? The x value is being multiplied by 3, our slope. So the slope, let's write this too right here. Slope is the multiplier that we call the coefficient on x. It's the, what are we doing to the input to get the output? So the x value changes by a multiplying it by 3 every time. So for every new one run, every new x value of 1, we have an increase of 3 times that to get the y value. So the slope, you have to see the connection there, what's going on, okay? Questions, anyone? So slope is what again? Rise over run. Slope is rise over run. How much do you rise to get from one point to another on that line? And how much do you run to get over to that point? So rise is how to get straight across from it. Run is how to land on it, right? Okay, so let's go here and let's identify the slope of these lines. Without having a graph, without having a table, just having the equation, just having the function. Okay, y equals 3x. What's the slope of that one? 3. We just did that one on the front, right? Number 2, y equals 2x. What would that one's slope be? 2. X is being multiplied by 2. So the slope is 2. What about y equals x? 1. Because before this got cleaned up, it looked like this, didn't it? Yeah. So put that in your notes, that y equals x really came from y equals 1x. It got cleaned up, which makes the slope 1. Y equals 2/3 x. What's its slope? 2/3. Yeah, we can have a fraction slope also. It doesn't have to be an integer value. Okay. So now we're going to do finding the rise and the run between the 2 points that they give us, tell what the slope is, and then write an equation for that line. So we have these 2 points right here that they've already graphed for us on the line, so let's use those to do rise over run. So the rise is, in other words, how much by the way, you can start at any point you want, and you can either go up or down. You do not have to go from a bottom point to a top point. You can go from a top point down to a bottom, it doesn't matter. Okay, so you guys go ahead and do yours, and I'll do mine. So I'm gonna go up to Would you do that draw on the graph like I did, where you showed the going up and down? Okay. So you only need one of them. You don't have to have both, but you know, I want to see if both of them work out to be the same slope. So I'm going to, most likely, we typically want to use the positives if we can. So is your rise 2?
Yeah.
Yep. And the run is 1. So that would mean we would put the rise upstairs, the run downstairs, 2 over the 1. What does 2 over 1 simplify to? What does 2 over 1 simplify to? 2. Okay, so the slope is 2. By the way, if I did that the rise is -2, and the run, so going down till I'm straight across from that bottom point, I gotta head left this time, which is in the negative direction, so that's a -1. What would that simplify to? What's a negative over a negative? A negative divided by a negative? A positive, and 2 divided by 1 is 2. This is still 2. So it doesn't matter which point you start with, okay? But if you don't want to have to deal with negatives and can avoid them, then start with the bottom point and go up to the one above it instead, okay? So what would our equation be then? What would our function be? Y equals something. Y equals 2 what? X. This 2 says that the rule is take the slope tells us the rule. Multiply the x value by 2. It's the multiplier. How are the x's changing? They're getting multiplied by 2 to get the y values. Let's see if that works for those points. If I take this x value of 1 and multiply it by 2, do I get the y value of 2? Is 1 times 2, so the x value? this is our x, this is our y, is 2 times 1, 2? Yeah. 2 and 4 is on this line. I would take the x value times 2. What's 2 times 2? 4, and I would get the y value. So this works, doesn't it? Yeah. Okay. You try the next one on your own. Number 2. Get a rise, get a run. Write that rise over run. Simplify it if it can be. Write an equation. What'd you get for a rise?
2.
2. Okay, what's your run?
3.
3. Okay, me too. So then what's the slope? 2/3, because rise over run. How much vertical change is there over how much horizontal change is there? Can 2/3 be simplified? Can 2/3 be simplified? No. So I'm just going to circle and say there's my slope. Okay, well now that we know that the slope is 2/3, are we ready to write our equation? Okay, what is it? Derek, what you got?
Y equals 2x.
2x?
Or 2/3x.
Yeah, how about 2/3 x? Huh? The multiplier is 2/3. The slope is 2/3. So we would write y equals 2/3 x. Okay, everybody got that down? Okay, so what is this really telling us to do here? It says y, you can get the y by doing what? Multiplying the x by you can get the y by multiplying the x by
By 2/3.
you can get the y by multiplying the x by 2/3. This was not a trick question. Okay. Okay, let's go to the next one. Says we're supposed to know we have to draw lines with using the slope and a point. Oh, okay. Well, what would be the smart thing to do? Start with a point, right? Okay, go put that point on your graph. 0.42. So go plot ordered pair 4, 2, first of all. And then this slope, let's go over here and say slope is 1/2. What is the 1 representing again? What is that? The rise. So let's write that behind it. The 1 is the rise. What's the 2? The run. Okay. So from that point, we are going to rise 1 unit and run 2, and both of them in the positive direction. So up and right. So we're going to go up 1 and over 2. This is not easy on my graph. But I want us to have, whenever we graph, we're going to just get in the habit of always having 3 points. 3 points. If this was a -1 over a -2, would that still be a positive 1/2? What's a negative divided by a negative? Positive. So wouldn't that still be a positive 1/2? So let's try this, because if it worked, if we can use this rise and run, these 3 points should line up on a line for us. So we would go down 1, so this is still a rise, even though we're going down, we're falling. And this is still a run, So let's go down 1 and over 2. And can you put a ruler through those 3 points? By the way, I think we should probably, at least this point, let's put its ordered pair name so we know where we started at it over here. Okay, so that one. Can you line up a ruler through your 3 points?
Yes.
Okay, I'll see if I can. This is not fun when I can't see the lines. I can you? Smack dab through those 3 points. Will your ruler go through? Let's see, figure out how to hang on tight to that rule so you get those lines. Okay, so now I want to draw something to your attention. This one, we do not know how to write the equation for yet. Because tell me about something about all of the, this one we should, I guess I'm wrong, we should, my thing is just off, isn't it? Yeah, my line needs to go, don't pay any attention to mine, please. Yes, wait.
Does it have to go like?
Yep, I want it all the way through the graph, yep. Draw your line all the way through the graph, always. So line it up through the points like that. Yeah, and draw it all the way through. Okay, put arrows at both ends to show that that line really goes on forever and ever.
Why do you?
Why? Because there's lots more points that live on that line, and then if I asked you to find some points where you be, no, we're not only focusing on that, we're using those to help us draw the line. So that's why we have those to help us, and then there's a whole bunch more points that really could be on this line. Okay. It doesn't say to write the equation, so we're not going to worry about that today. Yours is going to look different than mine. Yours should be going through this origin. Is it going through it? Is yours going through the origin? Good. Okay. Okay, number 2. Draw the line with a slope of 1 that goes through the point 2, 2. So 2, 2 is where we're going to start. So we're going to go to ordered pair 2, 2 and plot a point. And our slope is 1, so that means it doesn't have it only has a rise, it doesn't have a bottom, does it? It doesn't have a denominator. What can we make 1 into a fraction by doing? What can we do to that? How do I make any whole number into a fraction? Put it over 1. So this really is the same as 1 over 1. 1 equals 1 over 1. So this is our rise, and this is our run. It's rising as much as it is running. Yes?
Why did you write 1, 1? Because it's 2, 2.
No, I'm talking about slope here. This is ordered pair 2, 2. Wait, okay, that's the 2, 2 right there. But now we're going to go from that point using a slope of 1. So we're trying to figure out how do we use the slope of 1 to make more points starting there at 2, 2. Okay. So we're going to go up 1 and we're going to go over 1. But what else could we do? Instead, we could, you know what, let's go crazy making points this time. Up 1, over 1. Up 1, over 1. Okay, let's stop going crazy in that direction. Let's go the other direction. Instead of going up 1 and to the right 1, what other option do we have?
Down 1 to the left.
Down 1 to the left 1. So we can go down 1, left 1. So in other words, 1 is also the same as negative 1 over negative 1. So we can keep going down 1, over to the left 1. Go crazy and make a, well, let's have 3 points on either side of it. Just, these points are so close to each other. Now take your ruler, line them up through those points, and draw yourself a good line going all the way through your graph, and use your ruler. Okay. What's going on here? I can't get the straight line here, girl. Are you doing this? Holding on tight? I'm not touching that ruler while you're drawing. And I think this time I might be able to draw a better line through it. I'll try. So that mine looks like yours. Okay. Got a line going through all 7 points. Okay, you try the next one totally on your own. Go. And I want you to make some points above it and below it, please. When you're done, will you check mine out for me, please? Since you are the experts now, will you tell me if I have mine right? I better draw my line before you get after me. We're going to go a little bit above and beyond in this one too, and we're going to name the point above ordered pair 1, 2, and the point below. So go name those points. Give them their ordered pair names also. Name them over on the other side, kind of to keep it. So like over here, that point and this point. Would you name those 2 points? What are their ordered pair names? Okay, who's got the ordered pair name for the one just above our given point? This one right here. No, I want this. I want this point right here. Can anybody give me the name of that one? Wade?
2, 4.
2, 4, he says. You guys agree with him? Okay. Who can give me the name of the one right below our given point, which would be that one? What's that one's name? Sam?
0,
0, 0. Okay, everybody agree with Sam? Okay. Now, I want you to pay attention to how the slope also works in the ordered pair names. Okay, so follow along with me here. The slope is 2, which means the rise should change by 2. What's the rise? What's the up and down? The x values or the y values? What changes when going up and down? The x's or the y's? The y's. So this is really the y's. And what changes when you go left and right? The x's or the y's? The x's. Okay. So it's the y change over the x change. So our thing says the y should be changing by 2's while the x's are changing by 1's. Let's check to see if that's happening. So to get from this point right here to this one? Did the y go up 2? 2, 4, did it change by 2?
Yeah.
And did the x value change by 1? 1, 2? Yep. Okay, let's check this one with it. Did the y value change by 2? Went from 2 to 0. Did it change by 2? Yep. Went down 2, but so it's a negative. Did the x value change by 1? Went from 1 to 0. Is there a change of 1 in that? Yeah. So we should be able to see the change also happening in our ordered pair names besides. Okay? Okay, let's do one last one here. Ordered pair 3, 2. Let's get that one graphed. And this one says it has a slope of 2/3. Well, it's already got a numerator and a denominator. It already has a rise and a run. Would -2 over -3 be the same? Is a negative divided by a negative also a positive? Yeah. So we can also use this name for slope, -2 rise over a -3 run. So let's write them both down and let's use both of them one time, okay? So starting at your given point, use it's right there. And draw a line going through your 3 points, and if a line won't go through your 3 points, there's trouble. Like mine. Like I couldn't see my grid lines well enough. I'm going to change this point to be on my line. I only get to change my point. You can't change it unless you had it in the wrong location. You can't force it to be on the line like I just did, because I can't see grid lines. Okay. We should actually be able to write equations for all of these. Anybody think they know the equation of this graph? What would the equation of this graph be? Has a slope of 2/3 from our other page. What did we do when we knew the slope? How did we write our equation? Y equals, what would it be for this one? Y equals what? 2/3 x, yeah, there you go. Y equals 2/3 x. When it goes to the origin like all of ours are doing, it has a slope. We can write it just saying, put the multiplier, the slope on the x, and you'll have your equation. Okay. You done?